Yeah, so I suppose Eva kind of gave us a nice introduction there. We're going to just do a little bit of a background on ourselves and the company. I kind of have to assume that there's people, you know, on the event that don't know much about us yet. So just to start, hello, it's myself and Vincent McCormack, who's over here.
Hello everyone. I'm here as well.
Yeah, so we're based in Newcastle West. We're very proud Limerick folk. I think like a lot of people on this event this evening. So just to give you a bit of a background about GKinetic Energy Limited and where it all started. So we're HydroKinetic turbine developers, and HydroKinetic basically just means it's like Eva was talking about there. Hydro is one of the oldest established forms of power generation. HydroKinetic just means that you're generating power from free-flowing water, so you're not using a head of water or height differential in the water to generate the power. So these are just like plug-and-play solutions that you drop into a flow of water, and you don't need to do any kind of major civil works like dams or anything like that. So obviously the various ways that you can deploy hydro solutions, you know, there's tons of different ways you can deploy them, loads of different sizes. And there's been increasing interest in smaller hydrokinetic solutions, especially in recent years, just because the demand for energy is growing exponentially all the time. So basically the company started out back in 2011 with Vincent, who really just started as a hobby. We're a family of keen sailors. We've kind of grown up on the water, have, you know, real love for the water and the oceans and the sea. So really it just came about from Vincent's time sailing, and he just observed a phenomenon where the flow was accelerating when it hit an obstacle, and basically just started doing a bit of research in his own spare time. And I suppose over the years it gathered momentum, and he started to realize, you know, nobody's done this before, and it just kind of organically grew from there. So the last 9 years have seen extensive R&D and testing and prototypes developed. I think we've taken a very patient de-risked kind of approach where we haven't gone too big too fast or built like huge devices really quickly. We're very keen on, you know, doing it step by step, making sure that it works at a certain scale before moving along. So we want to become a leading provider of hydro energy solutions that are going to be really innovative, I suppose, for unique scenarios, and the CityxChange project is a great example of that. So basically, I'm trying to keep you awake because it's a Wednesday evening, so I'm trying to be witty. But it really did all start with a boy, not in the usual sense, a nautical boy. So Vincent was out on the water, and he was trying to tie up to a mooring buoy, and the tide was so strong that the whole buoy was nearly completely submerged. And he started to just watch how the water was actually behaving, started doing a bit of research into it. And the whole concept behind GKinetic is that you're accelerating the flow of water due to an obstacle, and that you place turbines either side of that obstacle where the flow has been accelerated, and therefore you get more power out of it. So that's it in a nutshell. So it involves 2 vertical axis turbines, and they're placed either side of this obstacle, or what we have coined as a bluff body. And we have built out a significant patent portfolio on that, and I'm very pleased to say that we've got patents granted all over the world now on the bluff body concept. So the key things that it does, obviously it increases the speed of water into the turbine, so therefore you get more energy and you can harness more power. But a big thing for it is that it makes the turbines viable in low flow speeds. And that's really important because we get loads of unsolicited inquiries all the time for our turbines, and it's usually in sites where the flow speed is lower. Because in the majority of, you know, rivers and flowing bodies of water, the average kind of flow speed is usually not more than kind of 1 meter per second. And a lot of competing devices, you know, great devices, they're making great progress, but a lot of the time they need 2.5, 3 meters per second in order to actually be viable, and there's very limited amount of sites in the world that have that kind of flow. So the other side of it with the bluff body is it's environmentally friendly, because due to its shape it diverts debris away from it. The unit itself is very compact, it can be fixed or floating, and it's scalable, so it can be very much adapted. So this is just a video. I hope it's playing properly. But this is the crux of the concept again. So you can see it nicely there, kind of going from a drawing into the real life scenario. So you've got the bluff body in the middle, 2 vertical axis turbines either side, and the water hits the front of the bluff body, and the accelerated flow then is being captured by those 2 turbines either side. So yeah, I'm not going to bring you through the last 9 years, but it's been a long road. We've got an awful lot of people that we could thank along the way, but these types of devices, it's called deep tech or deep technology. It requires years and years of very capital intensive work. This type of innovative solution doesn't just happen in a year or two. So in a way it's challenging in itself, because, you know, lots of funds and things like that are out there for startups, you know, they're for mobile apps or retail products, and we're really in a realm of our own where this has taken a number of years to get to where we are. So these are just some examples. Like the picture on the left is like way back when, kind of like 2011, where they literally, when they had the idea, they just kind of like the Wright brothers just went off into a shed and said, just build it, you know. So yeah, there's a real I suppose proactive attitude in the company of just getting metal wet as quickly as possible, and it's something that we're proud of, and I think it's reason of why we've gotten to where we are so quickly. I won't go further into the team, but if you have questions, I suppose, more about the background of the company, you can flag them up afterwards. One project that I do want to draw attention to, and one that we're really proud of, is we did testing in the Limerick docks in 2015. So anyone who's familiar with the city, that's in where Shannon Port Company have their main wet dock. It's 440 meters in length, and it's actually just the perfect testing environment for devices like ours. So we had done a bit of lab testing kind of in 2014, that had gone really well, and we were looking for, you know, the next step up. We didn't really want to be in a lab anymore. We wanted something that was more like the real environment, and Shannon Port Company couldn't have been more supportive in helping us to set up basically a custom tow test facility. We got visitors from all over the world, from like literally China, Asia. We had people in from, you know, really big marine energy conferences that wanted to come in and see the site, see the device, because you could literally stand at the side of the dock and see the device being towed. It was really unique experience, and it was hugely successful for us, and just an example, I suppose, of how keen we are to keep as much of this in Limerick as we can, because the benefit is, you know, it's great press for the city and the county, and it shows that, you know, we're leading these flagship projects, and we should try and keep them at home as much as we can. So we were funded by SEAI, so the Sustainable Energy Authority of Ireland, for that, and they have been fantastic supporters of GKinetic pretty much from the get-go. And the other things that allowed us to do, so we got to employ a couple of people. You know, this is a very niche area of renewable energy, and it's fantastic to be able to facilitate people who are keen to get into that line of work. So we also had a PhD who he did his whole thesis and PhD around the project in the Limerick docks. So just I know Aoife already touched on this, just I suppose, but reiterating the fact that hydro in many shapes and forms is you know, it's all over the world. People are looking to these solutions. So case study, you might have heard about it, but in 2018, so Falls Hotel and Spa in Ennistimon in County Clare became the first hotel to run on hydroelectric power. And they got phenomenal press out of it. It was a really good news story. And when the river there is in full flow, their hotel is 100% powered by the river outside their window. So it just goes to show that this is very doable. While that would have been more, I suppose, traditional hydroelectric power, like what Aoife was talking about, other more innovative, not more innovative, but I suppose just newer solutions that are adapting to kind of smaller scale deployments, they're happening all over the world as well. So an example would be ORPC, who are based in the US, and they have a really fantastic project in Alaska that has been years in the making, to be fair, but they've just secured a 10-year license to continue on with their device there. And their device is quite different to ours. It's actually submerged. It sits on the bottom of the river. It's quite large, so you would need a much larger river to deploy it. But now the community, who was 100% reliant on diesel generators before this project happened, they now only use diesel as their emergency backup power, and all the rest of their main source of power is coming from the river. So I suppose talk a bit more specifically then about how GKinetic got involved in CityxChange. So basically we joined, there's 32 consortium partners, and we were asked to join the project specifically for the role of assessing the potential of renewable energy production from watercourses in the city. So that was kind of step one. So part of that work was carrying out feasibility studies, hydrology studies, and then, you know, again, a staged kind of process where making sure, you know, obviously first thing was, is it feasible? Is there a suitable site to do this in? And then just branching out on that, carrying out hydrology studies. And we're kind of really at that stage now, which is why this event has come in good time, because I suppose really now we're looking to implement a deployment, and what we're proposing to do first is a singular demonstration of just 2 turbines, and then provided that that goes well, that we would install subsequent turbines after that. So we're just starting to look at the planning, permitting, you know, the turbine design itself, build, installation, and we're really keen to talk to all the various stakeholders, get, you know, just any, I suppose, ideas, concerns, anything like that, because this project really is going to rely on, I suppose, the support of all the stakeholders and the local people around it. So just to quickly mention, and again, my apologies if this goes over some people's heads, but the CityxChange project, the crux of it is this positive energy district or positive energy block, and the original positive energy block with the river was, what you can see it here, the square outlined, that was the original space that we did a feasibility study on. And what we found from that was, I suppose, the characteristics of the flow, both in terms of depth and flow speed, but then also it's a very busy area in terms of stakeholders, and, you know, you've got a lot of people using that stretch of water. So for a number of reasons, GKinetic decided that it wasn't really feasible to put in I suppose, enough turbines to get the power that we needed from this project. So we started to look further afield, and the site at Thomond Weir, I suppose, basically has emerged as by far the best site, the most suitable site for a number of reasons. So flow characteristics, it doesn't have as many people passing through it for safety reasons. And what that meant was just the page was revised. So it's still the original page that you can see in the square, but it's just now been extended to include Thomond Weir. So the Thomond Weir itself, I might pass over to Vincent at this stage, because as it starts to get more technical, he's definitely better. But yeah, again, not sure how familiar each of you are with Thomond Weir. We won't go into too much detail, but yeah, do you want to?
Thanks, Roisin. My God, yours for a moment to talk, and it's great to get a break, because I'm usually doing all the talking, and now Roisin's finally got up to speed and things, and it's great to get a break from it. So yeah, Thomond Weir, as we know, it's an old ESB installation that was put there for catching salmon long ago, and it's pretty much unused at the moment now, but there's quite a bit of interest now from Limerick City and Council and local stakeholders to see what can be done with the structure. And it just, I suppose it's just the timing of it is good, because for us, we're kind of arriving on at the same time. In terms of a structure, it's very suitable for installation of turbines, for us, for our type of turbine in particular. So yeah, we've done a survey, we've done the first phase of hydrology studies, which would indicate that we can get the decent flow speeds through it, sufficient to generate power. The next stage for us would be to do a second phase hydrology study, and that will predict what will happen when we put one turbine in. And what we want to do is we want to put one machine in with zero risk of flooding or any interference to anybody else, and to do an assessment of one turbine in a very de-risked type scenario. The model that we will do, the hydrology model that we will do, will try to predict what will happen with that one turbine. And based on the accuracy of the model, we can compare that data to the actual data that we get from installing one turbine. And that will inform us then on what the effects of installing 6 turbines will be. And that's a very, I suppose, safe way of approaching the project. Instead of trying to go and put everything in one go and trying to get funding for everything, this is a much more de-risked approach for us. Just on the technology, another little bit about it. So the first thing that Roisin showed you a free floating type device with the turbines mounted to the other side of it. But we actually get the same effect by controlling the flow through some of the openings, so it's diverted through one opening. So let's say control the flow through 2 openings to divert the flow into one opening, gives the same effect of accelerating the flow through the turbines. The turbines themselves are designed to operate in that up against the wall, I suppose, for want of a better description. So we would expect very good efficiencies from this. We've already done tank testing in a flume of a very similar type installation. So this just gives you an idea of the scale of the turbine. You can see a little man on top of the weir itself, and those are the weirs, the weir openings along there and the weir piers. And there's, yeah, you can see it there. So yeah, just this would be the one installation. The single installation would be a pair of turbines and some flow control measures in adjacent openings, and that would be determined by the hydrology study. So yeah, so environmental considerations, this is something that we are very conscious of as well. So at the moment we have a machine in Bordeaux in France, we have in the River Garonne in France. We've done measurements of noise emissions, we've done measurements of power, we've done measurements of flow, how the flow behaves around the machines. And so far so good, you know, there's nothing really sticking out that's a problem. Turbines rotate very slowly. I suppose to describe it, it's called the tip speed ratio, basically how fast are the blades turning compared to the water flow around it. And the blades in our machine turn at pretty much the same speed as the water flowing past it. That would be very different to the likes of your horizontal axis turbine, like a wind turbine, where you see that blade whopping by. Ours rotate like this, you know, they're going around like this, and as they go around, they're only traveling at the same speed as the water. So yeah, so those type of things have been blockers for turbines, you know, in terms of environmental impact, and this is one of the, I suppose, the key benefits of our technology. The other thing is there's no gearboxes under the water, there's no seals under the water, there's no oil under the water. We've got some specialized bearings that's the only moving part down there, so there's no risk of pollution there. So yeah, so CityX is very exciting for a number of reasons, I suppose. Our prototype demonstration is just our first phase. What the next phase would be to engage with the community, the local community, to set up a community enterprise that will run a renewable energy company. And that is part of the CityX, one of the CityX deliverables. GKinetic will just be a supplier into that enterprise. So in other words, we're not installing turbines and making money off them for the next 20 years. We just want to demonstrate our machine and get an order out of it, great. But the main reason we want to be in Limerick is it's right on our doorstep. It's like it couldn't be a better demonstrator area for us. We intend to bring people from all over the world to see what we're doing in Limerick, and that would be, you know, in terms of money making, it's not a money making project for us, but it's by far the more benefit we're going to get from this is the PR and the whole like in CDX, I suppose, outside of installing the turbines, the other work that's gone on in there is almost the setting up of new structures that decentralizes power generation and who's benefiting from power generation. So these are other benefits that are going to happen within the project.